Find the area of the triangle described below. And the description is they're giving us the length of all three sides. There's no angles here. All three sides. So when you have all three sides and you want to find the area, you have to use Heron's formula. Okay, the first thing you need to do to use Heron's formula is to find the semi-perimeter. The semi-perimeter is half of the perimeter. So you'd add all three sides and divide by 2. In our problem, this means 5 plus 6 plus 7 divided by 2. 5 plus 6 plus 7, that would be 18 divided by 2, which is 9. So the semi-perimeter is 9. Once you find the semi-perimeter, you plug it in this formula. The area is the square root of S, and now subtract each of the sides in turn. S minus A, S minus B, S minus C. So with our numbers, this means the square root of 9, 9 minus 5, 9 minus 6, the next side, and the last side is 7. So 9 minus 7. And now, since they ask you to round to the nearest hundredth, you can just enter all that in the calculator, but my preference is to just just simplify it a little bit before I put in the calculator. So this would be 9. 9 minus 5 is 4. 9 minus 6 is 3. And 9 minus 7 is 2. Okay, what is that? 9 times 4 times 3 times 2, that is 216. So this is the square root of 216, and the square root of 216 is 14.69, 3846, rounding to the nearest hundredth. That would mean 2 decimal places. So looking at this, that's bigger than 5, so this becomes 70. So this will be 14.70 units squared. Find the length of the missing side. And they give us a triangle. In this case, I have a picture, but remember that they might give you just the values of the letters. So they might say little a is 16, little a because that's the opposite to capital A, angle A. And so they might say little a equals 16, little c equals 25, and capital B or beta equals 97 degrees. So they might just give you the values of the letters instead of the picture, or you can draw a picture yourself. Either way, in this situation, we have this triangle. In what situation is this? This is the SAS situation, the side, angle, side. We know two sides, and we know the angle between them. So this is one of the two cases in which the law of cosines applies. Remember, there's two cases where the law of cosines is meant to be used, and those two cases are SAS and SSS. If you have in your hands one of these two cases, you're going to use the law of cosines. If it's any other case, then is the law of sines. So this is for sure the law of cosines. So we're going to find little b. This is little b because it's opposite to capital B. Alright, so applying the law of cosines, it is what? So this, I imagine this to be like the hypotenuse. Imagine this for a second that this is a right triangle. It's not, but so this is like the quote-unquote fake hypotenuse. So that means this would be b squared equals a squared plus c squared. But then because this is not a right triangle, there's a correction. The correction is minus 2ac cosine of the angle between these two sides, which is capital B. So that's the law of cosines. Now we're going to plug in our numbers so we can figure out what little b is. So we get small b squared equals a squared. A is 16, opposite to capital A, so 16 squared plus C is 25 squared minus 2 times A, 16 times B, times the cosine of capital B, which is 97 degrees. Okay, now let's see what is these two. What is 16 squared plus 25 squared? 16 squared plus 25 squared, that is 881 minus, now let's put this part in there, 2 times 16 times 25, that is 800, cosine of 97. Okay, now take squared on both sides. B is going to be the square root of 881 minus 800 cosine of 97 degrees. That would be the exact answer. But of course, we're going to put in the calculator because we want to round the answer to the nearest thousandth. That means 3 decimals. So let's see what we get. I want the square root of 881 minus 800 times the cosine. Again, make sure it's in degrees. Cosine of 97. And that is 31.28. And I want 3 decimals, so 1 centimeters. So that was an example of the law of cosines. They might just ask you for other things, such as now find also the angles. In that case, you could use the law of cosines again, just changing the perspective using another side as your fake hypotenuse. Or you may use the law of sines, because at this point then you would have one pair known, one pair of an angle on its opposite side. Find the area of the triangle below. And they are giving us a triangle where we have two sides and we have the angle between them. So this is a side angle side situation. For this type of triangles, there is a little formula for finding the area. The formula is area equals 1/2 times the product of the two sides, which in this case are A and B, right? We know little a, the side opposite to capital A, and we know little b, the side angle to capital B, times the sine of the angle between them, which is capital C. Okay, so we just plug in our numbers. The area is 1/2 22 times 27 times sine of the angle between them, which is 105 degrees. Now let's put this in the calculator and round to the nearest tenth. So that means 1 decimal. Okay, 1/2, I'm just gonna enter it as 0.5 because that's easier. Then times 22 times 27 times sine of 105. So we get 286.8799704, and rounding to 1 decimal, that would be 0.9. So 286.9. And this is what? This is square feet. Find lowercase a in the triangle below. And in this problem, they give us a picture with everything already labeled, but they might just give you the values of the labels, the values of the different letters, and you can draw your own picture. Either way, we have to find lowercase here, and we have to think, what case do we have here? What type of scenario is this? Well, we have two angles, and we know a side, this one, that is not the side in between the angles. So that means this is this case. Two angles and a side, not the side between the angles. The side not included. So we know then that this is not the love cosines, because the love cosines is when you know two sides and the angle between them, or all three sides. So that means this is definitely not the love cosines, it is definitely the law of sines. Or another way you can reason that this is the law of sines is because we actually have one pair that is fully known, one pair of an angle and its opposite side. Whenever you have one such pair that you know both, then you know this is the law of sines. An angle and its opposite side. Okay, so either way, we're going to use the law of sines. We're looking for lowercase a, so that means we're looking for this side right here. So we're going to compare the proportion between this side and the sine of this angle, and with the proportion of this side and the sine of this angle, because the law of sines tells me that all those proportions are the same. So what do we get then? We're going to get 6 over sine of 40 degrees, so that pairing, equals this pairing. So this is going to be little a, or lowercase a, over sine of 28. Okay, now you solve for a from here. We can cross multiply and divide, or just multiply by sine of 28. We're going to get that a equals 6 sine of 28. All that divided by sine of 40. And that would be the exact answer, but we want a rounded answer. We want to round the answer to the nearest tenth. So let's put this in the calculator and get an approximate value. Okay, so this is going to be 6 times sine of 28 divided by sine of 40. Rounded to the nearest tenth, meaning 1 decimal, that would be 4.4. 4.4 centimeters. Okay, and that's it. We found lowercase a. On the actual exam, they might just ask for everything, meaning for that angle as well and for that side. All you have to do to find this angle would be, well, you have two angles. To find the third one, subtract from 180. And lastly, to find this side, you can just do the log signs again.